Okay, dear students, let's now factor nth degree trinomials. So these are trinomials, meaning there are three terms, right? But these are nth degree, meaning it's not just quadratic, but it's like some even powered trinomials, like fourth degree. You will see one more here and here. But these odd degrees are also trinomials, and we'll look at that in a little bit. So all you have to do here is do the regular factoring, the X method factoring, where you have negative 24 on the top and 2 at the bottom. And so you have 6 and 4 that will work for you, 6 and negative 4. So normally you would have written this as n plus 6 and n minus 4. But since this is a fourth degree polynomial, I would write it as n squared plus 6 and n squared minus 4. So this could still further factor. So n squared plus 6 times, this is a difference of squares if you see. 4 is 2 squared. So you can write this as n squared minus 2 squared, and hence this is n minus 2 n plus 2. So that's how you factor a even powered trinomial. Okay. But here you see there is odd power, but you will also see that there is W everywhere. So there is a GCF going on here. As I told you, GCF is the first thing that you have to check. So the GCF is W, so factor that out and you will get a regular quadratic to factor. Okay, I'll leave that to you to factor. This is really simple. And likewise with the 17th one. But 18th is similar to the 15th question in that you have to first factor the GCF out, which is this. And then we have to actually do the X method on this because it's a fourth degree trinomial. So this with the X method in mind, I'm not going to do that in detail, but you will get X times X squared minus 5 times x squared minus 1, sorry, plus 1, because, hold on. Yeah, this is not 5, this is 25, my bad. X squared minus 25 and x squared plus 1. So this x squared minus 25 can be further factored out as x minus 5 and x plus 5 because 25 is a perfect square. And this becomes difference of squares. Okay, so one thing you should remember though, according to the fundamental theorem of algebra, the degree of the polynomial gives you the number of roots, whether they are real or complex. So if you actually look at the number of x that is present in the polynomial after you factor, so here this is 1, 2, 3, and 4 and 5 because there are 2 here. So you have 5 x's, meaning that is a fifth degree polynomial. So you should be able to equate the number of x's that you find after you factor, and that should be same as the degree of the polynomial. Then you're good to go. So it's another check in the end. All right. So yeah, that's it. So you can handle these two because these are polynomials, trinomials with degree leading coefficient other than 1. So I will leave definitely that to you, or let me try one. Let's try this one. Okay, this actually it is looking like 2m squared, sorry, 3m squared, and this is 2 squared. I just have to check if this is middle term is 2 times 3m and 2. So 6, 12, m squared, my bad. But yeah, it is. So this is actually a special product. 3m squared minus 2 squared. Right? How simple is that? And this is 4 because m squared times m squared is m to the 4. So our fundamental theorem of algebra also satisfies here. All right. This is an interesting question. So let's move on to 4 terms. How do you factor a polynomial with 4 terms or a quartic polynomial? Okay. So In this, you have to actually use the grouping method. So they have given an example here. Let me do with a question here. Normally, usually people put the brackets or parentheses around to make the groups, and it gets so confusing because there is a lot of scope for error, because this minus or the plus sign inside will be usually overlooked and it will be treated as a product. So weird mistakes that happen here. So I usually don't like the parentheses way. I put them into trays here. Just think of two trays at the bottom. This is one tray with one group. This is another tray with the second group. So, so what you need to do is, within each group, try to find the greatest common factor, right? So what is the greatest common factor in the first group? It is x squared. So pull x squared from each of them, meaning divide each term by x squared. You will get x minus 1. Okay. Do not forget to carry the plus sign, whatever is there over here, to here. Okay. Now in the second group, 9 is the GCF, so it's 9 times x minus 1. Right. Now if you actually see, the x minus 1 here should be the same as x minus 1 here. Okay. If it is not, something went terribly wrong, you have to go back and redo it. Okay. So now this x minus 1 comes out. You are factoring x minus 1 out because it's a common term between these two terms per se. So you're just left with, if I divide this expression by x minus 1, I'm left with just x squared. And if I divide this term by x minus 1, I'm just left with the 9, right? So the answer here is x minus 1. You just write what is left out, and that's your answer. Okay, let's do some more. Let's do the 24th one. Okay, again, put them into buckets or trays, however you call it. Okay, so in the first one, the GCF would be 2x to the 4 times x minus 9, right? Carry the plus sign carefully, and 7 is the other factor, x minus 9. See how they both are same. Now pull x minus 9 out, and you're left with 2x to the 4 and plus 7. Okay, so this is your answer. Okay, now I'll do one more. I have time for one more. So let's group these two together. Right, so this is one group and this is the other. So the common factor here is v squared, and 4v minus 5. Carry the sign carefully down here, and the common factor here is 4v minus 5. Why minus? Because negative times negative is a positive. Okay, so when you are pulling the negative out, it means that you're dividing by a negative. Plus divided by minus is a minus. Okay, so that's the reason why I wanted to do this question. And now you see that 4v minus 5 is same in both, so we're good to go. So we pull that 4v minus 5 out, and you are left with v squared and minus 4. So v squared minus 4. But v squared minus 4 is again difference of squares, so you are drilling some more down. So you have to like go even further. This will be v minus 2 and v plus 2. Again, how many v's are there? There are 3 v's in the final factoring method, and then the degree is 3. So our fundamental theorem of algebra is also satisfied. So that's it. This is how you do the grouping method. Okay, I hope this helps. Do let me know if you have any questions. Try the other problems also, and I'll see you next time. Bye.